Good afternoon, everybody. How are you all? This is Dr. Nandi. I welcome you to this presentation on interpretation of stem and leaf diagrams. I will give you some tips at the end, so please do not leave in the middle. There will be some important tips that I will give in the middle and towards the end of this presentation. Okay, so without further ado, let me share my computer screen with you. So you have stem and leaf diagram. This is a data set from a sample. The leaf represents the ones digit. So there are a number of parts. Find the 5-number summary, find the interquartile range should be, find the location of the lower outlier boundary, find the location of the upper outlier boundary. Is there any outlier in this data? Is the data set skewed? And at least 75% of the data will fall between which two numbers. So this is a stem and leaf. The stem, the leaves represent um, the ones digit. That means uh, the stems are in the tens digit, and leaves in the ones digit are in the ones digit. That means, when we'll take the first number, stem is 1 and leaf is 1. So this will be equivalent to 1, 1. Okay. Similarly, 1 and 5 will be equivalent to 1, 5, and so forth. So the stem is in the tens place, the leaf is in the ones place. So I have to find the 5-number summary. So I will use TI-84 to do this calculation. I will enter the data in the L1, list 1 of my calculator. Okay. So the first step is clear the memories of the calculator. So second button, then plus button, then number 4. You get clear all list on your calculator screen, all list. And then hit enter and you said done. So this is clear the memories of TI-84. So this is the first step we will do. Then, so second plus, then second button, then plus button, then number 4. Okay, so I should write this is number 4. And I get clear all list in my calculator, and then I hit enter, I get done. Clear the memories of TI-84. Then I hit stat and 1. Stat and 1. And then 1, which is edit. Enter data in L1. Okay, so as I said, the first number is 11. Next number is also 11. Next number is 15. Next number is 15. Then there are 3 19s. I'm entering all this data in L1. The next stem is 2. So the first number with a stem of 2 is 22. Next number is 22. Next number is 23. Then 25. Then 27. Then 28. The next stem is 3. So the first number with 3 stem is 30. Next number is 30. Next number is 38. Next numbers are in the stems 4. So first number is with stem 4 is 44, then 45, then 47, and then 48. Okay. Next is stem 5. So the first number with stem 5 is 50, 51, 53, 53, 55, 56, and 58. So I entered all the data in L1. I'm ready to get the 5-number summary. So if I move this a little bit up, so I'll do stat. I'll press the stat button. After entering data, after entering data in L1, L1 stands for list 1 in TI-84. Okay. Then what do we do? Press the stat button. Then highlight calc in the top row. Highlight means move the cursor on top of calc and then press number 1. Okay. So this will give us one var stats. Var stands for variable. One variable because we entered only data in L1. So my one var stat screen, first line will be list is L1. Second line frequency list should be empty, nothing there after the colon. If there is something, you can bring the cursor on the right of frequency list and hit clear. And then you put the cursor on calculate and hit enter. Calculate and enter. So we are looking for the 5-number summary. Okay. So the 5-number summary. Let's see. 5-number summary. Number summary. What are the 5 numbers in the 5-number summary? First one is minimum, which is 11. My second number in the 5-number summary is Q1 or first quartile. 25% of the numbers are below Q1. Then number 3 is median or 50th percentile. So I keep scrolling down with the down arrow key to get these things. Median is 30. Then I further scroll down to get the third quartile. That means 75% of the numbers are below the third quartile. And then I look for the max. Oops. So I have to take care of that. Give me a minute. Okay. And my number 5 is max, which is equal to 58. Okay, so that's my first 5-number summary. That is part 1 of this problem. Okay, now let me move up a little bit more. And then I have to find the interquartile range and the lower and upper outlier boundary. Okay. So, part 2. Is interquartile range. Interquartile range is the range of the middle 50% of the numbers. So interquartile range also in short form is written as IQR. So IQR, middle 50%, that means 75th percentile minus the 25th percentile. Okay, so my Q3 is, this should be 50. So my Q3 is 50 minus my Q1 is 19. So this is my interquartile range. This is the range of the middle 50% of the numbers. Okay. Now, let me move this a little bit up and I will calculate the lower outlier boundary. So let me change the color of the ink. So number 3, lower outlier boundary. Okay. The reason for finding this is any number in the data set lower than this lower outlier boundary will be an outlier, will be an outlier. Okay, so how do I find the lower outlier boundary? So the formula for the lower outlier boundary is Q1 minus 1.5 I times IQR. So my Q1 is 19 minus 1.5, my IQR is 31. So I can plug this calculation in my TI-84, type it just the way it is written is 19 minus 1.5 in parenthesis, means in bracket 31. And the answer is minus 27.5. So this answer is minus 27.5. Okay, this is the lower outlier boundary. So now I ask, is there any number less than minus 27.5 in the data set? And the answer is no. This is the question. So I have asked this question. Answer, this is. So let me correct this clearly, right? Answer is no. Okay. Then let's do the upper outlier boundary, but let's create some space for ourselves. So the upper outlier boundary. So the upper outlier boundary. And the reason upper, sorry, upper outlier boundary. You boundary. Any number greater than this upper outlier boundary is an outlier. Okay. And the formula for the upper outlier boundary is Q3 plus 1.5 times IQR. Okay. So my Q3 is 50 plus 1.5 times IQR interquartile range is 31. And this is 50 plus 1.5 parenthesis 31. And the answer is 96.5. Ask. Now I'm going to ask. Is there any number? Is there any number greater than, this is number, greater than 96.5? Answer is no. So no outlier on the right. On the right. And previously we found out no outlier on the left. So basically there is no outlier in this data set, neither on the right nor on the left. Okay, so that completes part 4. Now if I move up a little bit and see what else they want me to find out. At least 75% of the data set will fall. No, they asked me first, is the data set skewed? That is what I have to answer. Is the data set skewed? So let me change the so part 5. Is the data set skewed? Skewed means heavy on one side. So my first tip is a data set is skewed to the right if the mean is greater than the median. Vice versa. If the mean is less than the median, then the data set is skewed to the left. Skewed means heavy on that side. So the tip is find the mean and the median. Find the mean and the median. Okay. So let's see. So we have already done this. We will repeat this. Stat, calc highlight, number 1, list is L1, frequency list is empty, calculate. So the mean is, so this is sample, right? So X bar, sample mean is 33.85. And sample standard deviation, SX, is sample standard deviation. Standard deviation is equal to 15.73. And median is equal to 30. Okay. So what do we see? Mean is greater than the median. So we are now going to make the decision whether it is skewed to the right or to the left. If the mean is greater than the median, this happens only because there are too many large numbers pulling the mean to the right of the median. So this data set is skewed to the right. So that is my first tip. Find the relative position of the mean and the median, or positively skewed. Okay. Okay, so that's part 5. Now let's create some more space. The last part they ask between which two numbers does 75% of the numbers fall. Okay. Part 6. Oops. Give me a minute, I'll fix it. I'm going to do a little better. Okay, so erase this. So part 6. Between which two numbers, between which two numbers does 75% of the data fall? Okay, that is the question, last question. Okay, so use Chebyshev. So we will use Chebyshev theorem, which states at least 75% of the data will fall within 2 standard deviation of the mean. So this is my tip number 2, that at least 75% will fall within 2 standard deviation of the mean, which we get by using the Chebyshev theorem, within 2 standard deviation of the mean. So we have to find x bar, sample mean, minus 2 times Sx for the lower boundary. So my x bar is 33.85 minus 2 times my standard deviation is 15.73. So if I do that calculation in my TI-84, writing it the way it is written here is 33.85 minus 2 parenthesis bracket 15.73, close the right bracket or right parenthesis, and the answer is 2.39. And similarly, x bar plus 2 times Sx is equal to 33.85 plus 2 times plus 2, this is plus 2 times 15.73, and this is equal to 33.85 plus 2 times 15.73, and the answer is 65.31. 0.31. So if I create some space, so between 2.39 and 65.31, 75% of the data, 75% of the data will fall. I should say at least. Let me erase that and write it properly. So at least, this is important, at least. Okay. At least 75%. What is that? Let me At least 75% of the data will fall. Comes from Chevy-Chef theorem, which I have mentioned before, Chevy-Chef's theorem. Okay. Now notice if you do stat calc 1 and calculate, my minimum is 11 and maximum is 58. In this data set, minimum is 11, minimum is 11 and maximum is equal to 58. So conclusion is 100% of my data, 100% of the data will fall between 2.39 and 2.39 and 65.3. That's okay because I said at least 75%. That means the lowest is 75%. It can be higher than 75%. And as we see, in this case, 100% of the data will fall between 2.39 and 65.31. Okay, so I will stop here today. If you have any question or comment, write me a note. If you like this video, please give me a thumbs up. I really appreciate that. And if you like this video, share with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button. I'll come back next time with another interesting problem, interesting solution. So please don't forget to visit my channel next time, okay? When I will solve another problem. Take care. Have a nice day. I'll see you next time. Thank you.